Hi, my name is Mia Moore Walker, and my project is assessing the nutritional impact of decomposers or isopods on soil fertility. So, why? I really wanted to do a project that's centered on a problem. So, I started off researching different problems that were going on in the world, specifically with ecosystems, and I came across the fertilizer crisis. So, Political and BBC find that we are currently in a fertilizer crisis in countries like Africa, India, and even the US, as fertilizer prices are rising drastically. It's projected that by 2024, it will actually triple, which makes it really hard to get access to it. So I started thinking, what's a good way to replace fertilizer? And I came across the concept of natural fertilizers. Natural fertilizers are being decomposers. The National Fertilizer Institute reports that fertilizer is responsible for producing the big three: nitrogen, potassium, and phosphorus. There's three things that are imperative in leading to agricultural fertility and good plant growth. Funnily enough, these are the exact things that decomposers produce. So, boom, there was my project idea. How do isopods increase soil fertility through nutrient production? Okay, so I found a study that was done by Northwestern, the college, specifically Tung Chuan Lee, where they had two conditions: an experimental, which was treated with decomposers, and a control. Each group had leaf litter, except the experimental was the only one with isopods. My study runs in a similar way, but with more groups divided by concentration. And unlike this study, where they measured CO2 output, because that's a really good way to measure decomposition rate, and decomposition rate is what produces the big three, I just measured the big three independently because I don't have resources for things that can measure CO2 rate. Okay, on to materials and methods. So for materials, I had 12 transparent acrylic fish bowls, which were randomly placed and assigned a label of control, low, medium, or high. Each bowl was filled with 4.5 cups of potting mix and 5 PCs, which were added in the exact same spot in each bowl. Approximately 10 milliliters of flora and fauna or leaf litter were added to each bowl just to jumpstart decomposition. Then the isopods were added. So the bowls that had the control label received no isopods, the ones with low received 2, medium received 4, and high received 6 isopods. The peas were watered every 2 to 3 days and received flora and fauna once a week. Every 7 days, I measured the concentration of nitrogen, potassium, and phosphorus, and then I measured the pH. This was done using you can kind of see it over here, Luster Leaf Rapid Soil Test Kit. The measuring process including collecting 50 milliliters of soil, mixing it up with water, leaving it to rest for 24 hours, and then measuring it using color-coded solutions. Then I took the data, recorded in an Excel sheet, which is accessible through my poster, and then I had the results. Okay, so the overall results showed that an increase in the presence of isopod did have a very big increase in the fertility of the soil, which is really big because that's what I was going to prove with my study. It also showed that the soil had an ideal pH, and one of the big things I wanted with my project was for the person to be able to see it. And it was shown that the groups that had more isopods had a higher germination rate. Germination rate is just the sprouting of the overall peas. For instance, for the groups with high, they had more bowls where all 5 peas sprouted. Whereas with control and low, there would only be 2 peas, maybe 3 peas that actually germinated. So we got to actually see the effects of increasing the concentration of decomposers. But yeah, that's my project. I really wanted to highlight that fertilizer isn't the only way to lead to soil fertility. Yeah.